Okay, I'm back. 150. Pause this, copy this down. I do apologize, but they're very hard to write on this board, so the handwriting is not the greatest. It says things like transportation of weathered rock. That's what erosion is. This says mass movement, gravity. So pause and copy this now to your best. I'll talk about it in just a second. Okay, so usually weathering and erosion goes together. Weathering is the breakdown of rock from a mountain or just a bedrock of earth into smaller pieces. We just saw some weathering of that rock coming loose from that mountain, and then it rolling down the hill is the erosion. It's just transportation, the movement of it. Okay, so transportation of weathered rock. The agents of erosion, the things that do erosion are things like streams and rivers, glaciers, wind, mass movement, which is gravity, which is what we just saw. That's rock slides, mud slides, rock falls, things like that. There is erosion along the beach where the waves pushes sand a lot, and humans as well. Though humans really, it's like not very much of this. It's mostly about the other ones because humans do very little in total in all of this. The main agent of erosion on Earth currently is this, streams and rivers. Currently, that is what's causing the most erosion on Earth. In the past, during ice ages, it would be glaciers, but currently, the last few thousands of years has been streams. So, here we go. Please pause and copy this. So deposition is like a deposit, okay? When sediments are deposited or settle out of water, or even when those rocks would fall off the mountain, they just fall into a pile. That'd be deposition of it. Or we often look at the sediments. It sort of can provide like a clue to what happened in geology. We look at those, and we look at, this is how we sort of will look at sediments. Now, it may not sound exciting to you. I hope it does sound exciting to you. Like, we're going to look at that pile of dirt. Yay. But in the world of geology, that is kind of exciting when you can see different, what may have caused that pile of dirt or sand to be there. So sediments can be sorted, and our definition of sorted for this is going to be not random with sizes. The sizes are some sort of order or pattern to them. They can be unsorted, which means they are random. They could be smooth or scratched, either one of those. And sediments can be rounded or angular, and different types of erosion will cause them to be either round or angular. Let's get into some of them now. So here we go. Okay, so this is what I usually ask students to do. I'm going to ask you to do this. Write it on your paper. If you get it wrong, you just cross it out. That's fine. Go to each one of these and write whether you think they are sorted or unsorted. Those are your two choices. Each one's going to be sorted or unsorted. Don't forget, sorted means not random. Pause this, do that now, write it in. If you get it wrong, I don't care. We'll cross it out. Okay, hopefully you've done that. Now I'm going to go through the answers here. So hopefully what you got here, this, unsorted, because it is kind of random with sizes. Unsorted, this, all exactly the same size, all really rounded too. That would be sorted. This one, sorted, because it's not random. It has this weird, unique type of sorting of largest to smallest, so that's cool. This, sorted, because larger, a layer of smaller, and then a layer of like medium size. So that'd be sorted, and then this, unsorted. So it should look something like this. Hopefully you had that. As a matter of fact, if you want to write vertical sorted in there, you can. We will learn more about that. That means as you go vertically, which is straight up, they go in some order from largest to smallest. Okay, cool. Here we go. Please pause this and copy. Okay, so agent of erosion, the first one we're talking about is mass wasting, maybe really mass movement. It's erosion by gravity, okay? It's often assisted by water. We saw in the one video in Taiwan, and it was raining really hard because what happens when it rains, it adds a lot of weight to the soil, to the ground, it adds extra weight. The water can provide some lubrication, reduces friction, and that's when you get rock slides and mud slides mainly, is when it's rained a lot. When it has rained a lot, the deposits, the pile of rocks, looking like this example here, they're going to be unsorted, just a pile of large, some large and small and medium mixed in, and they're going to be angular, okay? So for them to get rounded, they need to do a lot of tumbling and hitting other rocks, like years and years and years of it. And here, it just fell 30 feet. You don't have that, so they're going to be unsorted and angular. It has stars next to it because that's an important thing for you to know for this. And some are quick, some are slow. I'm not getting into details here, but soil creep happens really slowly, you know, that much a year. Really slow. It takes many decades for this to happen. Slump is a little bit faster, it's a little bit moves. Landslide or mud flows pretty fast. It can be quite fast. And rock fall is just falling through the air, mainly, or down the hill. That can be really fast, as we saw in that one video. So that's just examples of it. We're going to do this. We're going to skip this because this could be this long drawn out thing. We're not going to do it. We're going to skip it. You could just write skip on yours and we'll go on to the next page. This is some kind of pretty awesome drawing that I did. I'm known for my earth science artwork. There's this. I'm not going to, this was, I think a kid had a question once and I was like, just like winging it. Another piece of great art. Man, I'm good, but we don't need that for today. Next up, this is going to be wind erosion, okay? So wind erosion mainly occurs in the desert, occurs in areas that are dry, like the desert. I will say this, side note, how do you spell desert versus dessert? They're very similar. One has two S's, one has one S. The way I've always been taught since I was a kid, dessert has two S's because you want more dessert. It has more S's. That helps you. Maybe you knew that. Only moves fine sediments, sand, and silt. So you really what it is the wind blowing sand. The wind's not going to blow a boulder, you know, that's this big around. It's not going to, it can't do that. It doesn't have enough force, but it blows a lot of sand. And sand can sandblast things. So sand hitting a rock day after day, year after year can actually erode, weather down that rock. So we see that here. The wind will be blowing this way, hits the sand, and flattens the rock in that way. So that's called sandblasting. That's called a ventifact. Sandblasting here, this could be a rock that stood out of the ground, and the sand goes along the ground mainly if that's a person, and it really wears away the bottom, not much here, because the sand usually blows along the ground, and it can do that, which is crazy, really cool looking. Your desert pavement is when all the sand is removed by wind. Just a thing I threw in there. This is not super important, the desert pavement, but what do we got next? Okay, this is kind of important. Please pause it and copy it now. Okay, I'm going to zoom in a little bit because I am. So wind deposits. So this is like sand dunes. This is when the wind will kind of stop and deposit some sand. This is what we often get. The sand grains themselves are pretty rounded because they're hitting other sand grains, right? And over years and years of them tumbling, it's called abrasion. Hopefully you know it's called abrasion. The edges will worn down, so they're kind of rounded. They'll be really sorted because if you have if it's depositing sand here, the bigger rocks it never picked up, they left over here, and the finer sand, the smaller pieces get blown, keep getting blown. So it's sorted. They could be frosted, which I'll talk about a little bit, but that's only if you look really, really up close at the sand, and cross-bedded. That's what I really want to focus on, cross-bedding. That's this pattern here. And what you have is only time sediments are not deposited flat. So mostly sediments are deposited flat. Or at least by streams they are. So what you have is the wind's blowing this way and the sand will bounce along or roll along here and then it rolls off the cliff and it gets deposited. It's protected from the wind. So you have all these layers that are at this angle. And if the wind changes, it kind of makes this layer really flat at the top. And now it's going this way and now it deposits the sand at this angle. And after many, many years of it, what happens is you get this pattern here. It's called cross-bedding. And what do I have? That's the formation of cross-bedding. So that's pretty cool. Doesn't mean that much to us in New York because we don't have that kind of climate. We don't really have any cross-bedding here other than from rocks from really, really long time ago when we were more desert-like, but not just something you commonly see. Okay, this is a picture in Utah. You probably can't see it too well, but this is cross-bed here. Actually, you probably can't see it too well, so I'll skip that. So what I have here, this is going to be like when something's frosted, the sand grains can be frosted. Think of frosted glass. This would be like beach glass, and this is glass that ends up in the ocean, like trash ends up in the ocean, and the sand keeps hitting it, and the sand has a higher hardness and will scratch it, and then it gets really rounded on the side, and it's like kind of cool looking. People collect this. People make jewelry out of it and everything. I mean, I don't have any beach glass jewelry, but I don't really have any jewelry, but some people do. Here's more of it here. You can see it's the color of like glass, green glass, clear glass, some blue glass, brown glass. Blue glass is kind of rare, but That's just frosted glass. I just threw that in there. 92 years of beach time lapse. This video won't work for us. Sorry about that. So, what am I doing here? Oh yeah, so I'm going to do some beach erosion. So beach erosion. Let me see weather. Right, so beach erosion. Now, sometimes I teach students. We're in New York. Some kids go to the beach all the time. Some rarely get to. But so what this happens here, look at this. This is a long, narrow area of land, water on both sides. And I can tell that the sand's getting pulled along here, getting moved along here, and being left here, being deposited here. And this is what we call the sand spit. This is in England. It's a really cool feature. And that's kind of some of the stuff we're going to learn about. Yes. So, please pause it and copy it now. I think I actually skipped the top part of it. I'll go back to the top part in a second. So we'll go back to there's another diagram above this, which I maybe lost track of. So what we have here, longshore current. So it's basically the waves there's a current that moves along this way slowly, and it moves sand along with it. So the sand here, you see the sand, it builds up right there. It's called the sand spit, and builds up there. So the sand gets moved along the beach, and waves are really strong, and sand is kind of small. So waves can really affect sand kind of quickly. You can have a lot of erosion in just a matter of days. So you really only have the wave and beach erosion near the shore, where it's the middle of the ocean, where it's 1,000 feet deep or 10,000 feet deep. You don't really have an erosion. That's just sediment settling out. Sand's moved along the shoreline. It's called longshore drift. The shoreline tends to be straightened out over time and leads to the formation of things like sand spits, barrier islands. Fire Island, New York is a good example of it. Let me see if I can get back to that. I think I missed it. Yeah, I lost track of that picture on this page, so I apologize for that. This file got a little crazy. That's okay. So ways to prevent wind erosion at the top of this page, you could just skip that. And then this area here, we'll just skip that as well. But we have this here, beach erosion. Here we go. So that should bring us to the bottom of page 4. Yes, okay. We did this. And let me see. I changed this a little bit. What do we got? Yeah, so I will say this. You probably don't have this. You don't have this. But you could write that maybe. Write this just on the bottom of that page or somewhere on the beach erosion page. Ocean wave and ocean current deposits, they're going to be rounded and sorted. So the sand you will have on the beach is going to be really rounded from all that wave action, and it's going to be sorted pretty much all very similar in size. So you write that in there. You don't have to really write this in. That's okay. Okay? As we go on to the next section. But first, I'm a big sand guy. Look, this is from Cape Cod, Massachusetts. Look how, so that's a really rounded quartz grain of sand. It's pretty rounded. So this is sand close up, one of my favorite things. Sand, I love sand close up. So this is sand close up. You've probably never seen it like this. And really rounded from that constant abrasion by the waves. Here's another sand spit here. So the sand, longshore currents go in this way. And then at some point, the sand will stop being moved and be deposited and built up all this land right here. This is in Maryland.